Hello and welcome to another walkthrough. Now this time it will be Edexcel IAL F1 May 2025, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough, I might be making mistakes, which I'll correct if I realize in the walkthrough. But if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of times, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. And here's the paper, and I'm going to start the stopwatch now. Okay, let's go. FP1. Number 1, okay, matrices. I'm just going to be writing here. Given the matrix there, M, where A is a constant, A not equal to minus 5 over 3. We got to be careful on that one. Part A, determine inverse of M in terms of A. Okay, so the inverse of M would be the determinant 1 over the determinant of M, and then in this particular case 2 by 2 matrix, we're just gonna swap between the A and the D, so the first one and the last one being swapped like that, and then put a minus sign on minus A and minus 3 like this. Yeah, okay, but the determinant we haven't got it yet, so determinant of M, or you might want to write like this, is just multiply down minus multiply up. So multiply down is minus 5, multiply up is minus 3a. And we're just going to put that into the form there, because it's just, so I can just take the minus out, so I can write like 1 minus 5 plus 3a like this. Yeah, and the matrix will just be again minus 5, minus a, minus 3, and 1. Or, I mean, you can put the minus sign outside to simplify the things inside the matrix instead, like 5a, 3, and minus 1, because that looks a little simpler than before, right? And that is just it, number 1, yeah, in terms of A. Of course, they tell you that A is not equal to minus 5 over 3, because that would have made it a singular matrix, which doesn't have an inverse, right? And this is the answer here. Okay, so part B. Given that M inverse equals 2M plus 8i, where I is the identity matrix, determine the value of A. Okay, so we're just gonna perhaps put the matrices into places here. So like we have the M inverse here on the left side of the equation. So I'm just gonna write all that. And then this is put equal to 2 times M, yeah? So I'm just gonna multiply this all by 2. So I'm gonna get 2, 2a, 3, and minus 10, yeah, follow? And then add that with 8 times the identity matrix. Well, the identity matrix is just 1, 0, 0, 1. You should all know that. So it's 8, 0, 0, 8, yeah, just multiply by 8. That should be easy. Okay, well, when you have a matrix equation like this, it's basically just, you can just basically equate each component separately. Yeah, that's gonna also work. Like, for example, if I take the first one component here, first row and first column, so it's going to be 5 times the 1 over determinant, that is 5 plus 3a. Yeah, this is the first component, equals, on the left side we have 2 plus 8. Okay, and that's it. So that's going to work now. Okay, so I'm just going to have that. Yeah, that can work. So we have 5 equals, so this is 10, yeah, times 5 plus 3a. Well, 5 can cancel that too, so this is 1 times 1 equals 10 plus 6a. So 6a equals minus 9. That means a is minus 3 over 2. Okay? Now, because we can never be sure, right? I mean, technically, if they don't ask, like, determine the value of a like this, maybe there is or there isn't the solution to a. Because we need to check other components, like what happened if you do, say, the other component, like, say, this one. Yeah, so let's take also that one. So 3 over, similarly, equals 3 plus 0, just like that, right? We're doing the other one now. 3 can cancel that, yeah, because 0 doesn't mean much. So I have 1 equals 5 plus 3a, yeah, okay. So, ooh, okay. Yep, we didn't expect that, did we? So, so I'm getting here, what I'm getting here is a equals minus 4 over 3, and not what we expect. Okay, yeah, here we go. So something is wrong. Yeah, it's good that I checked with the other component here. So let me double check my math again there. Minus 5 minus, I'm just going to check from the beginning, right? So if I write this correctly, minus 5 swap with 1 and minus a minus 3 here, yeah, that's fine. 1 over determinant, determinant is minus 5 minus 3a, yeah, that's good. I'm good with that. And we just take the minus out, we push the minus sign in here. So it's going to be 5a, 3, and minus 1, yeah, I'm happy with that. And then we write this as the m inverse. This is the 2m. Aha, I saw it. This is 6, right? Almost flopped there. Okay, here we go. Yeah. So this should have been 6. No, hang on. This should have been 6. Yeah, hang on. This should have been 6. All right, so we check the second row in the first column there. Just going to add a page here. So that's wrong. That means, so if we ignore the 0, we cancel 3 by 1 and 2 here. So 1 equals 10 plus 6a. You're going to get the same line as this, right? So again, a is minus 3 over 2. That means there is a valid solution to a, and a equals minus 3 over 2. Okay, I just checked with 2 components, and that's all you need to do, I think. Well, I mean, look at the bright side here. I checked the other component where I put the wrong number here. I mean, any harsh examiner would just deduct my mark away, right? They wouldn't give me a mark here if I wrote a wrong method, accidentally put a wrong number there. All right, but that's number 1, done. Okay, next question. Yeah, question 2. Matrices again. Now about transformation by matrices. Part A. The matrix P represents transformation P. Describe fully the single geometrical transformation by P. Now, it's easiest to just, go from the original basis or unit vectors. So this is the I unit vector, and this is the J unit vector. I hope you know what I mean. It's the I, the J, the unit vectors on the X and the Y axes, yeah? So you look at I down here and J down here. Yeah, look down. Now the change, what is the change? So that now, yeah, the I becomes 0 minus 1 and the J becomes 1, 0. So I would call that I prime and J prime after the transformation. Well, if you don't see clearly here, it is better maybe to draw some graphs here. Not exactly graphs, but you'll know what I mean. So I was this and J was this, yeah, and now I'm going to use a different color. So I and J are there, the original ones, unit vectors along the X and the Y, but the transformation matrix, yeah, represented by 0 minus 1, so I is going to be here. This is the I prime, the new I, and the J is going to be 1, 0, so like that one. Okay? So what is the kind of transformation that would make I become here and J become here? That seems like a rotation, right? So you gotta scope your choices a bit here. Yeah, so if you rotate clockwise by 90 degrees from the I and the J, the original ones, you're gonna get I to here, right, which is what we want, and J to here, which is what we want. That sounds like a matching transformation there. Okay? So to describe is just rotation at origin by 90 degrees. Yeah, I'll just say about. Yeah, clockwise, right? Because direction matters here. Yeah, so rotation about the origin by 90 degrees clockwise. Happy? Yeah, that's it. Part B. The matrix Q represents the transformation Q. Okay. Describe Q fully as single geometrical transformation. Again, same method, but now easier, because again you go from 1001 to 5005. So clearly you are multiplying by 5. What does that do? Well, enlargement. So it enlarges both x and y axes by 5 times. Okay? So this is going to be enlargement in both directions by a factor of 5. Yeah? Enlargement. Wait, hang on. Enlargement, one word. In both directions, x and y. You probably don't need to write these, but just to be safe, by a factor. Wait, hang on. By a factor of 5. Yeah, that's it. So that's the description of the transformation there. Okay, part C. The transformation R is a reflection in the line y equals minus x. Write down the matrix representing R. I mean, I don't remember. Let's say I don't remember, but let's use the same trick. So from 1, 0, 0, 1, okay, let's draw the graph as well. Again, the I and J were here, the original ones. Now you're going to reflect in the line y equals minus x. And the line y equals minus x is this guy. Okay, y equals minus x is that guy. You don't need memory here. I mean, honestly, I don't remember this. So I'm going to work it out fresh. Yeah. So this is the line y equals minus x. When you reflect those two unit vectors, what do you get? Well, expectedly, you're going to get j prime here, yeah, down here, and then I prime down here, up to the left, sorry. Right? Because that's how reflection works. You get to the other side of the mirror, basically. So we can just write the unit vector represented by the orange unit vectors here. I mean, we can write each one. So the I prime becomes minus 1, 0, right? This is minus 1, 0 pointing to the left. So I write minus 1, 0 here. And then the j prime is just 0 minus 1 in it. Yeah, so 0 minus 1. Looking down, yeah, for each column. And that is it. So therefore, write down the matrix representing R. So R equals, just reading the question again, yeah, minus 1, 0, 0, minus 1, like that. All right, that's the answer to part C. Part D, the transformation R maps the point 4, 3 to a point A. Determine the coordinates of A. Well, so when you use transformation matrix, you're going to write the transformation matrix in front and the point you want to map. And that's going to be the new point. Yeah, the new point you want to map. That is mapped by that transformation matrix. Okay, so this will be, well, you just multiply out. So minus 4 plus 0. Yeah, so that's going to be minus 4 on the top part here, on the first element there. And then this one is 0 minus 3. Yeah, so it's going to be minus 3. Okay. So the new point would be minus 4 minus 3. That's it. Okay, there you go. Right. Yeah, I think I'm fine with that. Okay. The transformation P followed by transformation Q maps. Part E, the transformation P followed by the transformation Q. So P first and then Q. So that's the order of multiplication. Maps the point B to point A. Yeah. So point B would be here and then gets mapped by this combined transformation. P first followed by Q. So you need to put P closest to the point you're transforming. Determines the coordinate of B. Aha. So this is A, right? So you do Q, matrix Q times matrix P times the point B equals point A. That means if you want matrix B, right? Yeah, you're going to have to do inverse. So let's multiply the Q. Let's call QB as a matrix M maybe. Yeah, can we use M? Yeah, M hasn't been used. So when we inverse the M, we can do like M inverse multiplying here and M inverse multiplying here. So that means when we cancel m on both sides, or when we multiply by m inverse on both sides, we're going to get m inverse times a. Okay, so let's just find the m first, right? So m is just q times p, matrix multiplication. So q was 5005, and then p was, what was p? That one, 0, 1 minus 1, 0. Yeah. Okay, so multiply that. So the first one is 0, 0. Yeah, so I put 0 here. And then what do we have? 5, 0. Yeah, I have 5 on the top right. 0 minus 5, so I have minus 5 down here. And then 0, 0. I have 0 here. Okay, so that's matrix M. That means the inverse of matrix M would be 1 over the determinant again. So multiply down is 0, multiply up is minus 25, so we plus 25 here, so the determinant is 25. And then the adjoint is just swapping a and d, so those are just still 0, and putting the minus on the other ones. Okay? Yeah? Well, you can just take the 5 out, right? So I take the 5 out, I still have this. Yeah? So you take the factor of 5 out from all the elements, where 0 doesn't do much. And then I can simplify the 1 over 25 a little bit. Yeah, just make it a little simpler there. So that means b equals 1 over 5, 0 minus 1, 1, 0 here. Yeah, multiplying with a, where a is what we got in part D. Yeah, if you got something wrong here along the way, you're going to lose some accuracy marks, right? Because there's a lot of follow-through work here, right? So I need to be careful a bit. Yeah, but I think I'm fine with that. So b would be, just going to do these multiplication first. So 0 plus 3, so it's going to be 3. And then minus 4, 0, it's going to be minus 4, right? And 1 over 5, so that is just, so point B is then 3 over 5 minus 4 over 5. Yeah, that should be the answer. Yeah, I think I'm okay with that. I'm going to go to the next one. At least these are the right methods to work on. Okay. Number 3. Given the equation if x equals 0 has a single root alpha in the interval that, use interval bisection to determine an interval of width 0.25 that contains alpha. Okay, so bisection, right? Bisection. Interval bisection, yeah, it's just this is similar to P3, I think, because if it's linear interpolation, it's going to be a little different, but this is interval bisection. So we're just gonna, but it already tells you the interval of 0, 1. Do we have anything in the formula sheet here? No? Interval bisection. Honestly, I forgot the name here. What's the interval bisection? You have linear interpolation and Newton-Raphson, and the other one is it's just, yeah, it should be just interval with the interval width of that. Okay. Right. I mean, of course, if we put 0 and 1 in, there should be a change of sign. I mean, I can see that. But it says interval of 0.25 here. That means we need to narrow down, and how are we going to narrow down that? To determine an interval width of that contains alpha. Okay, yeah, I think I know now. So yeah, it took me a while. I think I recall now. Okay. You're gonna have to do change of sign between 0 first. Okay, so let's do 0 there. So f0 is just 0 plus 5 minus 8 to the 0. So that's gonna be 5 minus 1 is 4. Yeah. And f1 is just 1 plus 5 minus 5 to the 8, right? Okay, so surely that's 6 minus 8 to the, that's going to be negative, yeah. Okay, so change of sign so that it contains a root, right? Now we're going to do f 0.5. Yeah, this is interval bisection. You go half, 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 yeah. Yeah, you keep having the thing. So you do 0.5 here and you will see the change of sign. So it's going to be 0.5 to the 2 plus 5 minus 8 to the 5 times 1 over 2. Yeah, we're going to get the value there. So 0.5 to the 2 plus 5 minus 8 to the power of 5 over 2 is 2.5. Wait, no. Yeah. Okay, yeah. Minus 175.7. I'm just going to stop at some decimal there. So this is suggesting that the root should be between the negative and the positive. So it should be between 0 and 0.5. So now the interval will be 0 and 0.5. Yeah, we update, and then because we already got the 0.5, so we just got to find half of that again and see whether the root is on the left half or the right half. Yeah. Yeah, okay, so this is 0.25 to the 2 plus 5 minus 8 to the 5 times 0.25. Yeah, and we should get that 0.25 to the 2 plus 5 minus 8 to the power of 5 times 0.25. That's minus 8.4, right? So that means the root is between the minus and the plus, because if we pick 0.5 and 2.5, they're both negative, so the root should be between positive, which is 0 here from this, and negative, which is the 2.5. So now the updated is that, yeah, this is the interval containing the root. And I think we achieved it because now we achieved the interval with a width of 0.25 that contains alpha. So the interval that contains alpha is 0 and 0.25. That's it. Yeah, that's the bisection there. Where x is in radians, yeah, gx equals that. Show that the equation gx0 has a root beta in the interval that. Well, this is simple, so we just do g of 4 equals, okay, so I'm just going to do, well, this is in radians, right? So 4 equals as an answer first, and then change that to radian already. So 3 to the power of sine answer, right? And down minus 3 times cos answer. There you go. Everything is right, right? So I get 2.396. Yeah, for that. That's G4. Now let's do G5. Yeah, this is just a change of sign, classic. So G5, right? So we're just going to change in that 5. Yeah, 5 straight. Nothing complicated there. Okay, so minus 0.502. All right. And there is a change of sign. There is a change of sign of fx while being, yeah, in recent papers and recent like syllabi, they require you to write while being a continuous function. Yeah, because if it's not a continuous function, then this method doesn't work. Okay. In interval 4, 5, therefore it contains a root. Yeah, okay, that's how you do it. Part B. This is part A. Use linear interpolation. Yeah, okay, to determine an approximate value for B, give me your answer to 4 significant figures. So basically linear interpolation, yeah. Just draw a graph first. We have a 4 and a 5 here. Maybe draw further apart a bit. And then, well, because at 4, we have a positive number. So this is the G4, yeah, being this guy. Yeah, so if you plug x equals 4, you get G4. if you plug x equals 5, you get g5, which is a negative number down here, which was 0.502, right? And linear interpolation says that, well, the root must be in between, which is this guy. This is the root, beta. Okay? So how do we linear interpolate that? Well, it's just using similar triangles, basically. So this triangle is similar to this triangle, but you have to be careful with all the sides. You got to make all the sides in the formula positive, yeah? So that means we're going to do height over base equals height over base. So basically g4 over the base, which is beta minus 4, because beta is to the right of 4, equals the height. Well, you got to make it a minus of g5, right? Because g5 is a negative value here, yeah? Divided by the base, which is 5 minus beta. All right? And that is how you interpolate. It's basically similar triangles under the hood, yeah? Well, I guess I need to get these values again, right? Because I didn't make it 4 significant figures, so I'm going to make it 6 maybe. So this one we already got is 2, 6, 6, 6, yeah, just to be safe. And let's make the other one again. But that's not 4. Just going to go up there and do it again. So 9, 6, 3, 5, 6. All right. Then we're going to take those rounded decimals. Let me double check that again. You can't be too careless. There. Wait, hang on. Was it? Yeah. Okay. And then we're going to plug them in. Yeah. So this will be G4 will be 2. Okay. You know what? I'm just going to shrink this down and, you know, move this up so that I can see while writing. Okay. So I have here, guess you can see that too. So 5, 2.396356 times 5 minus beta equals minus G5 is going to be a positive, so positive 0.502266, beta minus 4 there, okay? Yeah, okay, assuming I copied everything correctly, and then I'm going to carry on solving B. Okay, so if you multiply everything and rearrange, I'm just going to write beta equals right now. Yeah. So what do you get here? If you imagine, yeah, this one is going to be a negative beta. So I'm going to move that to the other side, right? And when you solve for beta, that's going to be down here. So 2.369356 plus 0.502266. I mean, if you solve the equation, you will see why. And then moving to this side for the number, I have 2 times 5. Yeah. There, 2 point blah, blah, blah times 5. And then, well, that is, if you multiply this and this, you get a negative. But when you move to the left, you get a positive. So that should be a plus. Wait, hang on. I forgot the times 5 here. Plus 4 times that decimal. Right? And then I'm going to plug that into the equation. Sorry, the calculator. Fraction 2.396356 times 5 plus 4 times 0.5022666. Yeah, is that right? Yep, okay, happy with that. And then divided by 2.396356, yeah, plus 0.5022666. So that is 4.827, the 4 significant figures, right? And does that make sense? Yeah, it's in between 4 and 5, so that should be fine. All right, so I'm cool. I'm good. Let's do the next bit. The next question is number 4, of course. The rectangular hyperbola C has equation xy equals 81. The point P blah blah t not 0 lies on C. Use calculus to show that the normal to C at P has equation that. Use calculus. Okay. Yeah, so we're going to do y equals 81 x to the minus 1 first. Yeah. Assuming you maybe haven't seen how to do implicit differentiation yet. Maybe not. This is the way to go. So dy by dx is just well, you're going to put the power down. So that's going to give you minus 81. And then the power minus 1. So you get x to the minus 2. But I'm just going to write x to the power of 2 down here instead. Just make it a little nicer. Like that, yeah, with a minus sign. So we want the gradient at x equals 9t. So dy by dx at that point would be minus 81 over, well, 9t squared would be 81t squared, right? Yeah. And that would make it minus 1 over t squared for the gradient. Yeah. And then I'm just going to do y minus y1 equals mx minus x1. So y minus y1 being 9 over t because it passes normal. Oh, hang on. This is normal. Okay. Normal to c at p. So we're going to do m normal is just t squared because it needs to multiply that to be minus 1. So yeah, so the same point p there, and m is just t squared and x minus x1 being 9t. So we just simplify all this. How about multiplying t to every term? So I get yt minus 9 equals t squared x plus 9t to the 3, like that. Is that right? Hang on. Multiply t out. Yeah. Hang on. Oh, it should be to the 4, right? Because we have t to the 2 and multiply t, and then we get another t in the brackets there. Now, if you tidy that up, well, writing ty there instead and push everything to the left side, I get t cubed x here. And then if you look at these two terms, you can factorize 9 out, and in the brackets you have 1 minus t to the 4. Wait, hang on. Oh, this should be a minus. Yeah, sorry. Yep, that's right. Yeah, it's good that they have this for you so you can check your work as well. The normal to see at P meets the y-axis at point A. We're just going to find the exact coordinates of A. So we just meet. So the normal we just found meets the y-axis at A. So y-axis, x equals 0. So x equals 0. We have ty equals 0 plus 9, 1 minus t to the 4. Okay, in terms of t, right? We want in terms of t. So the y coordinates would be y equals 9 over t, 1 minus t to the 4. Nothing particularly hard there. Just solve the equation here. But we don't need to solve anything. This is already in terms of t. The y coordinates is already in terms of t, right? So that means the point A would be, because this is on the y-axis, so x is 0. And then I have that whole thing. Yeah, for the coordinates. All right. That should be fine, point A. Part C, given that t equals 1/3, find the exact area of triangle OPA. The first thing I come up with in my mind is just draw out the triangle. So O is the origin. Now point A was the y-intercept, right? Yeah. And because this is 1/3, so that's going to make it positive, because if you try put 1/3 in here, it's going to be somewhere positive, right? So that's point A maybe. And then what was point P again? P is 9t and 9 over t. That's going to also be positive. 327. So that's probably about, let me think about that. I don't know. Yeah, I'm gonna make it around here, maybe. Okay? It doesn't really matter. P can be anywhere, but what matters is we need to find this area of the triangle. Yeah? Now, this is where most students struggle, because they would think, okay, do I need to find this angle, this length, or what? You just need a little creativity here. This is already the base. So you just need this to be the height or altitude. I mean, if you flip the triangle, you will see that this will be the altitude of the triangle, which is the height. And the height is just the x coordinate of P, right? Because it's just the horizontal distance there from point P to origin. And the x coordinates of P would be 9 times 1 over 3, right? And OA, we already know. We're just going to take the y coordinates we got here. Yeah? So it's just going to be 1 over 2 times 9 times t, which is 1/3, times the y coordinate of A, which was from the previous part. So 9 over t, which is 1/3, times 1 minus a third to the power of 4. So if we calculate all that, we should be good. All right. So 1/2 times, well, 9 over 3 is just 3, no? Yeah. And then we have, so 9 over 1/3 is just 27. Yeah. Just going to help the calculator with a little mental math there. 1 minus, well, 1 over 3 to the 4 is just 1 over 81, right? Because 3 to the 4 is 81. Yeah. And that's it. So that's exactly 40. Exact area. So I'm going to go with that and do the next question, number 5. Here. The complex number Z1 is given by that, where R is the positive constant. Complex number Z2 has modulus 5, given that Z1 times Z2 in modulus is 15. Okay, so part A, state the value of R. Okay, so we know that modulus Z1, Z2 in modulus here is equal to split modulus like this. Okay, yeah. Well, yeah, so this is in a polar form. You need to know that whatever R is, it is actually the modulus. If it's in a polar form like this, because the parts in the brackets will be a unit of 1. The length will be 1. So if you multiply that by R, the length will be R, which becomes what's called the modulus. Yeah. So that would be just R from Z1. This is 15 because the modulus of the combined Z1, Z2. And the Z2 has modulus of 5. So this is 5, basically. So R is just 3. Yeah, shouldn't be that complicated. All right. Now, part B, given further that Z1 plus Z2 is a real number. Okay. Determine the possible complex number Z2 in the form of A plus BI. Okay, so we're going to make Z2 A plus BI right now. Okay, so because you haven't done FP2, you will maybe later on, but I'm just going to make it Z1 plus Z2 here would be equal to. So from Z1 is R cos 7 pi over 6, right? Like that. And then you plus A. That's the real part. And then I'm just going to write the next line. And then the imaginary part, right? We're just going to do R sine 7 pi over 6. Yeah. That's from the Z1. And from the Z2 is just B. And then this is I, right? Now, because the sum of Z1 and Z2 is a real number, that means the imaginary part should be 0. So R sine, so R is again 3, right? 3 sine 7 pi over 6 plus B equals 0. Okay? And now we're going to determine the possible complex numbers Z2. All right, where A and B are constants. Yeah, what about A though? Okay, we'll find A. We'll find A, hang on. Oh yeah, okay, yeah. So we find B first. So sine of 7 pi over 6, well, that's the same as minus sine pi over 6, if you do the quadrant there, yeah. So that is sine pi over 6 is 1 over 2. So that should be minus 1 over 2. So this is B equals 3 over 2, if you do the math there, I believe. Yep. Well, that means Z2, right? Z2 is then something A is something plus 3 over 2I. So we don't know what A is yet. But the other thing we know is the modulus of Z2. Because the modulus of Z2 was given to be 5, remember? And that's going to be put equal to A squared plus 3 over 2 squared. Pythagoras there. Okay? So it's going to be 25 equals A squared plus 9 over 4. So A squared is 100 minus 9 is 91 over 4, right? So that means A is just plus or minus root 91 over 2. What is root 91? I mean, Yeah, oh no, it's not, okay, it's not a nice number. 9/4, let me just double check that. Yeah, I'm just gonna keep as 9/4. I mean, if I didn't make any mistake there arithmetically. Yeah, 100 minus 9 should be 91. Yeah, okay. So the possible complex number should be plus 91/2. And then the I is just one case, or Z2 equals minus 91/2 plus 3/2I. Just these two, yeah. Oh, we already determined the possible complex numbers, the two cases, and then we plot Z1 and both of Z2s in a single Argand diagram. So this is real part, this is imaginary part. So Z1 is just, what was Z1 again? Yeah, okay, Z1 was the thing up there. So what was this? This is the component for, so 3 cos that and 3 sine that is the components of Z1. So it's this is minus 1/2, right? Yeah, so Z1 is minus 1/2 R, so that's going to be 3 minus 3/2 minus, and also R sine, wait, it's cos first, so what is the cos? Cos, so 7π/6 is going to be a third quadrant, so that is going to be a negative cos value. So it's cos π/6, so that's √3/2, so minus √3/2. Okay. Oh, minus √3/2 times 3, so minus 3 √3/2. And then the y component of Z1 would be, again, we got it earlier, right? It's minus 3/2, yeah. So that. Okay, so we're gonna plot now. Z1 is around a third quadrant, so it's gonna be further to the left rather than down. So it's gonna be somewhere here. This is minus 3 √3/2, and then the y is minus 3/2. Yeah, so that's Z1. And then the two possible Z2, well, I think minus √39/2 is further away. Okay, so it's going to be further to the left, I think. Is it? So 9 times 9, yeah, it's going to be, oh, hang on, maybe not. 3 √3/2 is 2.5, yeah? And then we have √91/2 is 4.7, yes, further to the left. All right. Yeah. Okay, so that means it's about here. Minus √91/2. It's going to be put there. So let's make this a little further to the left, to the right, I mean. Yeah, and this is √91/2. So it's going to be the same horizontal. There. This is Z2. This is Z2. Okay, like that. Z2, because there are two possible points for Z2. So that's going to be Argand diagram plot. Okay, and of course this is the same as minus √3 over, wait, hang on, is a negative. Wow, okay. Wait, that's weird. This is minus 1/2. This is 3 minus 3/2. Okay, because that wasn't familiar to me. Yeah. Okay, so it should be oh wait, hang on. I'm a bit confused now. Z1 should be, yeah, this should be minus 3/2, right? But for the Z2 it's 3/2. Okay, sorry. Yeah. All right. It's a bit tricky there, right? I know. Okay, so that should work now, right? For Z1 and Z2. Okay, cool. Number 6, yeah, we're at 43. We should be okay, I hope. Oops, okay, yep. Number 6, if x equals that, the equation if x equals 0 has a root alpha and beta, state the value of alpha beta. Well, this is roots of quadratics, right? So the roots, the product of the roots is just minus 5 divided by 3. Because it's just minus the last one. It's just the last one divided by the first one. The coefficient of the last term divided by the coefficient of the first term for the product. Okay, so I'm just going to write this alpha beta equal that. All right. Part B, given that alpha plus beta is that, determine the value of k. Okay, so alpha plus beta is also minus the middle one divided by the first one. And this is given to be also equals to 9 times alpha plus beta, alpha times beta, which is part A there. So we can solve for k there. So the minus sign cancel. I'm just going to do, so 3 also cancel here. So k is just 45, right? Yeah, let me double check everything. Yeah, I think I'm happy with everything there. Okay, so it's just 45. C, by first expanding that, prove that. Okay, good. We're going to expand. So alpha to the 3 plus 3, well, maybe you can do Pascal triangle, 1, 1, 1, 1, 2, 1, and 1, 3, 3, 1. Maybe quicker than doing binomial using the formula. So the 1, 3, 3, 1 will be the coefficients. So here I already have a 1 alpha cubed, and the next one is 3 here, yeah? 3 alpha squared, so the first one reduced power by 1 from alpha to the 3 to alpha to the 2, and the beta gains more power, yeah? And then this one is also plus, again the same coefficient 3 because of the third term here, and then alpha reduced by 1, so it becomes alpha, beta gains 1 more power there. And then the last one should be beta cubed because it's symmetrical there, okay? So that is that. So that means, okay, I'm just going to write here, this thing equals alpha plus beta to the power of 3. Well, that means if we make alpha plus beta cubed the subject, we would shift these two terms to the other side, yeah, where I'm going to write alpha plus beta cubed as a subject, and then write like this first to show some working maybe. And then I'm going to factorize, as they have there, 3 alpha beta out, and then inside you would have alpha plus beta as required, yeah, like that. And then part D, without solving the equation of x equals 0, find a quadratic equation with integer coefficients that has root step. All right. So we're going to find, let's say we have ax squared plus bx plus c equals 0, yeah? So this is a new equation we're finding. So minus b over a, I mean, look, it's easier to do this, to have b over a x plus c over a like this equals 0 first, and then you will see what I mean. So the minus b over a is going to be, you know, the sum of the roots here. These are the new roots, so we add them up. So it's going to be alpha squared plus beta plus alpha plus beta squared. Okay? Well, seems like we're going to have to manipulate the algebra a little bit here, because we have the alpha plus beta already from the previous part, because it's still the same alpha plus beta here, yeah? But the alpha plus beta squared, right? So alpha plus beta squared come from the fact that we have alpha plus beta in a complete square first, like that. But because if you expand that complete square, you get extra to alpha beta, which you don't want. So you want to subtract that out, yeah? So now all this becomes just alpha squared plus beta squared. Make sure you follow that. Yeah, if you don't, just wind back. So this, the underlying term here, is the alpha squared plus beta squared, all right? And now we just put things in because these are what we know. So the alpha plus beta was just, what was it? So k was 45, so if we plug 45 back in here, we get this, which was 45, plug in there, and that's going to be minus 15, right? Okay, so minus 15 here, plus minus 15 again squared, minus 2 times the product, which was given to be, well, which was what we found in part A, minus 5 over 3. Right? Yeah. Okay. And then we solve for minus b over a first. yeah, it's going to be a little much there. Minus 15 plus 15 squared there, because minus squared is, yeah, going to cancel that. And minus 2 times minus that is going to be a plus. 2 times 5 over 3, like that. Ooh, so that's 640 divided by 3. Yeah, we will deal with the denominators later. That's just the middle term. Okay, that means this is minus b over a is the sum of the root. So b over a is minus that, right? So b over a is just minus this. Yeah. Okay, we're gonna keep that. You see, we can plug the whole thing in b over a now. And c over a would just be the product, right? So it's a product of these two. Yeah. Well, surely we need to expand this first. Yeah, so it's going to be a cubed. Probably the part c will be useful. Plus b alpha plus alpha squared beta squared plus beta cubed. Is that everything? Yep, it is. Okay, so we're going to have here, well, we got the alpha cube plus beta cube already, right? Because that's in part B. We just show that. And this is just plus beta alpha. And then that is just alpha beta squared, right? And the first term, the sum of the cubes there, is going to be alpha plus. We just take the part B result, yeah? We change to this, right? This is a bit much, I would say. And then plus, well, alpha beta, I'm just going to write alpha beta instead. And then another alpha beta squared. Okay, and now we plug in everything. Again, alpha plus beta is the sum of the roots from the previous parts, which was minus 15 again, yeah? So minus 15 cubed there, you got to be careful with the sign. Minus 3, this was alpha beta, minus 5 over 3, yeah? This is minus 15. This is minus 5 over 3 plus minus 5 over 3 cubed. This is horrible. A lot. This is a large, like a lot of, terms there. Okay, so calculator. Minus 15 cubed, yeah. Because that's going to be minus anyway. So this term will be, the second term will be a negative. So I'm just going to do 3 can cancel there, so it's just 5 minus 15, which is 75, so I'm just going to do minus 75 here. Yeah, that's the same term done. The third term is just minus 5 over 3, yeah? And then the last term is just plus 25 over 9, yeah? Wow, okay. So, yeah. That means the equation will be x squared, yeah, minus 640 over 9. Yeah, that's the b over a there. And then the c, this is x, and then the c is this, equals 0. Well, yeah, surely if we multiply 9 out, we get everything in integer here. Yeah. Find a quadratic equation with integer coefficients. Yeah, we should be fine there. Yeah, so just multiply 9 out, and then we got that equation. Well, if I have time, I'm going to go back and check on this question later, but I'm just going to run and do question 7 first. Yeah, because we can't be careless about time, right? Okay, question 7. Given this equation here, where p and q are real constants, given that that is a root, so the other root, right? Write down another root of fz equals 0. So it's just 3 minus 5i. It's just the conjugate of that. Part B, hence determine a quadratic factor with real coefficients of fz. Well, you have 2 roots now, yeah? So that means if you imagine you have 2 roots, and the way you would have got these 2 roots would be, I mean, if you like multiply them out, yeah, you will have another, hang on. Okay, yeah, so you have z1 and z2. Sorry, you have z1 and z2. So if you multiply them, just like the concept of quadratic roots here, you're going to get what? You're going to get the last term of the quadratic factor. This is the product of the roots. So multiply them, we get 9 plus 25, right? Because it's just the way it works here. We multiply the first term and the second term, we add them up. Because If you expand that, you will see it works like this. This is 36. And if we do z1 plus z2, right, you're going to get what? z1 plus z2, well, the imaginary parts will cancel. You just get 9. So this will be z1 squared, because the sum of the roots will be the negative b over a. Let's say a is 1 first. Yeah, we get that. Well, I don't need to write 1 here. Yeah, and then that will be plus 36. This is a quadratic factor, because before we got those two z's, we need to put this equals 0, and that would lead to 3 plus or minus 5i. That's how we got it, right? So this is a quadratic factor here, okay? Okay, a quadratic factor, then we will use this. Oh, we got the quadratic factor already, right? A quadratic factor with real coefficients fz. Yeah, there you go. We got it. That's part B done. Determine the value of P and the value of Q. Okay, so it seems like we have two quadratic factors, right? So if we do AZ squared minus BZ plus C times Z squared minus 9Z plus 36, you could do a long division, but I'm just going to try comparing coefficients here. Yeah. Well, this is when you have what you have before you will expand to the full fz there. But I did this because I know, yeah, because if you do c times 36, right? So 36c must give you 68. That's not a nice number. Oh, yeah. That's why. This is 34. Okay, I almost flopped again because of mental math. Poor mental math, maybe. Well, but it's still not that nice. Yeah. All right. I need to change this to... Oh, yeah, that's why. Oh, sorry, I'm confused. This is 34, so that means 34c must be equal to 68. All right, so c is 2. Okay, we got c is 2 now. Okay, and we can do the z term. So the z term, how we get the z term is this guy multiply this guy, and this guy multiply this guy, right? So we have minus b times 34, yeah, plus c times minus 9z equals 192z, right? Because it must match here. Let me double check everything again. I mean, you can't be too careless there. All right, so that means minus 34b, well, c is already 2, so that's going to be minus 18, right? Z will cancel anyway, so I'm just going to write Z as well. Equals 192. So that means b is, well, 18 plus 192 is going to be 210. Oh, okay, 210 divided by 34. It's not a very nice number there. Okay. Yeah, probably going to go with that. So minus 105 divided by 17. Okay. Probably we have to multiply everything out after we got everything. Yeah, okay, we're going to do that. And then A, so A is going to be equal to, because A needs to multiply this to get P. Oh, that's not helpful. Well, let's do the third power of Z, like the Z cubed, right? So we have this multiply this, and this multiply this. So minus 9A, yeah, right? That's one of them. And minus B would be equal to minus 36. So that means A is just minus 36 plus B, yeah, plus B, which is minus, because B is a negative number, and all divided by minus 9, right? So I'm just going to plug that in the calculator. Okay, so minus 36 minus 105 over 17 minus 9. Okay, so that is 239 divided by 51. I'm not liking that. Okay, that's fine. I'm seeing something. Because 17 and 51 are multiples of each other. So if I just write everything down here first, yeah, after getting everything, it's going to be this, which is not very nice. B is, did I seriously put a minus here? Okay, but hang on, let me just double check. That should have been just a plus, but okay, did I do it correspondingly? Minus B times 34, yep. Anything with a B, yeah? Okay, well, minus 9A here, hang on. This is set to the 3, so minus 9A, that's fine. And this is minus B, yeah? Okay, everything is corresponding, so I'm good. So because this is minus, B is minus, so that term is going to be a positive. All right, so it's just a positive 105 over 17. Sorry about the confusion there. And C will just be 2. Okay, so we're going to determine the coefficient of P and Q. Z squared minus 9Z plus 34. Now look, if everything have to be real constants, right? Perhaps we need to multiply out if Z equals 0, P and Q. Okay, well, I mean, I'm just finding whether they need to be an integer. I mean, I'm gonna guess that they do have to be integers. Yeah, so we're gonna multiply out by 51. So that would make this. 51 divided by 17 is 3. So 3 times that is 315Z plus 6. Yeah, we multiply 51 on the first term there. And this is just the same thing. So that means P is actually that, and Q is the second power. So what was it? Q would be this multiply this plus this multiply this. I'm not so sure about this question, guys, honestly. We will see. I mean, when I say that, I think if there's anything wrong, I should annotate the video, yeah, so you guys should see. That's a very huge number, right? So Q is the coefficient of Z squared. Yeah, I mean, oh, forgot the 6 here as well. So plus 6, hang on. This multiply that, yep. This multiply this, and this multiply this, plus 6. So that should be plus another 6, so it's 7 here. Ooh, okay. Yeah, I'm gonna go with that, I guess. Don't have much time to check. Without using a calculator, determine other roots of the equation if Z equals 0. I guess we already did that, which is this guy here. This guy gives us 2 previous roots. This guy, using a calculator, sure, you got it. This. So I'm just going to put 239 over 51, enter. 105 over 17, enter. And 2, enter. Enter. Okay, that is just exact. Simplest form? Oh my god, that is not very simple, is it? Alright, so 3 multiply out. I'm just going to have minus root that. Yeah, this is wrong. I think this is wrong. Minus 305 divided by 478. Yeah, right? What's the other one? Okay. Well, it's just plus or minus, right? Yeah. So plus or minus these. Okay. I'm just going to have to go with that. Yeah. All right. Wait. Without using a How did I read that? Okay. Without using a calculator. Okay. So how do we do those? Okay. Yeah, use formula, of course. All right. Z equals minus B plus or minus square root B squared minus 4 times A times C, like that. Yeah, you want me to do that? Yeah, okay, fine, go ahead, you got it. There you go. And then I'm just gonna take this anyway, because I don't know, I'm just gonna do it like that. Yeah, I think likely it might be wrong, but I just need to do the next question. If I have time, I'm gonna come back to check, of course. That would be what I do in the real exam condition there, guys, using the standard summation formula. Show that. Okay, so left hand side, I'm just going to write like that now, is going to be the sum of the 2 and sum of r squared minus, well, just the sum of 1, right? And it runs from r equals 1 to 2n. This is 1 to 2n as well. So the first one, if we use the formula, let me show you the formula, not that, hang on, where, this one. Okay, so we have the sum of r squared, which is this guy. So we're just going to put in brackets 1 over 6 n plus 1. Wait, so it's from term 1 to term 2n. So I need to change from n to 2n. So every n I need to put 2n. Every n I need to put 2n. Every n I need to put 2n, and that's going to become 4n. Yeah, okay, so that's the first term. Okay, and well, for this one, right, it's just because every term is just going to be 1, 1, 1, 1, 1. So it's going to be 1 2n times. So it's going to be minus 2n, basically. All right, so there are 2n terms of 1s. Yeah, then you have that, right? Yeah, let me check. Yeah, it should be fine. Okay, so we're just going to go back to the paper, and we need to simplify to get those. Okay, so simplify. Well, this is going to be 3 there. So we have 4 over 3. Yeah, that looks good. N, yeah, that looks good. Okay, hang on. Doesn't look good now. So we should multiply that out and subtract that by 2n. Okay, I'm just going to do this, yeah? This is, hang on, this is 1 over 3, so it's 2n, and then 1 over 3 of this whole thing, and then minus 1. So basically factorizing 2n out, right? To make it a little simpler there, so it's going to be 2 over 3n here first, outside, and then in the brackets, wait, no, I can't just take 1 over 3 out like that, no, sorry. Just going to simplify the thing inside there, so it's 1 over 3 of 8n squared, so the middle term is 4n, and that is minus 2n, so it's plus 2n here, minus 1, and then this is minus 1. So 2n in brackets, 8 over 3n squared, plus 2 over 3n, minus 1 over 3 minus 1 would be minus 4 over 3, you know? Yeah. And then we're going to take 1/3 out, right? And 2 out as well. So that's going to be 4 over 3, 1/3 and 2 together, yeah? And this will be what? Taking 2 out, it would be 4n squared. Taking 2 out, it would be n. Taking 2 out, it would be minus 2, right? And the third is also out. So 4 over 3n, and this would be what? I believe it's n plus 1 and 4n minus 2, isn't it? Oh, no, it's not. No, it doesn't work. Hang on. Or is it the other way around? Nope. Ooh, this is horrible. This is horrible because I don't get what they want there. 4n minus 2n is 2. Something is wrong with the calculation. I mean, like this should be 2, right? Yeah. Because if it was 2, then this would have been correct, right? So let's check backwards there. Would this be 4? I mean, this should have been 4, and then taken out, it would be 2. Is this actually 4? Well, 4 minus 2, nope. So I got something wrong on this one. Did I copy the formula wrong? 1 over 6, 2n plus 1. 2n times 2 is 4n. Yeah, that's right. That seems right. 2r squared there, yeah. I think I got every part correct there. And this is 2n minus 2n here. Hang on. 8n, 4. Oh, damn, look at that. Okay, the sign. Stupid. Yeah, now it is 6. Oh, wait, 6? Did we want 6? 4 times plus 2 is 6n. If we take 2 out, we get 3. Seriously? Wait, hang on, but the math will change, right? Would it? So this is 8n squared. This is 4 plus 2 is 6. And this is 1. And this would be 1 over 3 minus 1 minus 3 over 3 when you do that. So this is going to be minus 2, right? And this will be 6 instead, right? Okay, yeah. And let's do that again, yeah. So if I take 2 out, inside will be 4n squared plus 3n minus 1. Is that correct now? It's going to be 4n minus 1 instead. Yep. Okay, got it now, guys, finally. Okay, mistake hunting there, the process. You should learn that too. Okay, by proof by induction, we have this. Okay, all right, so for n equals 1, yeah, I'm going to be fast here. So left-hand side equals, yeah, so it's the sum from r to 1. So it's just 1. So left-hand side is just, it's just because it's only one term, right? It's just 1 times 3 times 1 minus 2 to the 2, which is 1. And the right-hand side is just 1 to the 2 times 1 plus 1 times 9 minus 7 over 4. So hopefully that should be 1, 2, 2, 9, 2, 2, yeah, 1. So left-hand side equals right-hand side. So true for n equals 1. Now, hypothesis step, assume true for n equals k. So we have sum of r from 1 to k. And then this is r, 3r minus 2 to the 2 equals, we sub in as k, so k squared, k plus 1, 9k minus 7 over 4, yeah? And then for n equals k plus 1, so we're going to do left-hand side. That will be sum of r from 1 to k plus 1 will be that, right? And then if we expand this first, right? If we expand this first, we're going to have, from the term being from 1, yeah, that's the first one, plus until we have k, right? Or we can do this, or we can do, I'm just going to write sum of r from 1 to k, yeah? It's just the second last term there from 1 to k, yeah? And then we're just going to add the last term. So substituted k plus 1 into the r, we're going to get this. So 3k, 3 times 1 is 3, minus 2 is 1. So this is going to be that, yeah? Just substitute k plus 1 into r. Okay, that's the left-hand side. So the right-hand side, we need to prove, and this we can substitute, right? Because it's what we got here earlier. So I'm just going to sub that whole lot to be k squared. Just going to move this also to the left. K plus 1 and 9k minus 7 divided by 4. So I'm going to plus that, yeah? Hang on, just double checking. Yeah, so 3k plus 1 squared. Now it seems like we need to do some algebra here, so I'm just going to factorize k plus 1 out of those two terms. And here I have k squared, 9k minus 7 divided by 4 plus 3k plus 1 squared, right? So we're going to simplify this bit first and see where that takes us and compare to the, the right-hand side here when substituted k plus 1 in, yeah? Here I'm going to have, that's going to be cubed. Okay. All right. Okay, so 9k cubed minus 7k squared, yeah, plus. So I'm just going to do the over 4 here as well for the 3k squared plus 1. So, okay, it's going to be 9k squared times 4 is 36k squared So 2 times 3k is 6k. 6k times 4 is going to be 24k, yeah? All right, so that's the middle term, moving to the left a bit. And then the last term is 1, but multiply 4, we get 4. And I'm going to merge that as like this. So we can take the 4 out, surely, because they have a 4 there for the right-hand side, and this is k plus 1. Well, hopefully we can take another k plus 1 out, and then a k plus 2, and then, yeah, you know what I mean. This will be 9k cubed. Minus 7 plus 36 is 29, is it? Yeah, 29. That's horrible. Okay, that doesn't seem like it's gonna... I mean, if we expect that we should get another k plus 1 out, right? Yeah, because it has n squared here, right? Because we need to get that form. N is k plus 1 in this case. So if we try put a minus 1 in here using factor theorem, yeah, if we get that to 0, we're good. We're good. So we're just going to calculate that, right? Mod normal. So it's minus 9. Wait, hang on. Minus 9 plus 29 minus 24 plus 4. Yes, okay. That's horrible math. Okay, so this is k plus 1 squared. Yeah. So I'm just proving that k plus 1 is a factor of this, basically. So after we take k plus 1 out, I'm going to just use a short division. I think I've shown you short division before in other videos, but I'm just going to be quick for this one. So 9, 29, 24, 4, and then I'm just going to do a critical value here, minus 1. So I pull that down 9. Just going to do another layer here. So that's minus 9, right? I'm going to add that to 20. 20 times minus 1 is minus 20. Add that to 4 times minus 4 here, add to 0. So the other factor in that is going to be 9k squared plus 20k plus 4. And hopefully we can factorize that, right? So that's going to be, because I know that we are expecting k plus 2 here. So I'm just going to do, k plus 2. And the other one should be 9k plus 2 as well, right? Yes, we got it. So this is rearranged into 1 over 4, k plus 1, yeah, squared, which is the n squared. And this is k plus 2, which is the n plus 1. And this is 9 of k plus 1 minus 7 in it, because it's 9k plus 2. Okay, so this is in the form n squared, n plus 1, 9n minus 7 divided by 4. Therefore, true for n equals k plus 1. Now, the concluding step, since it is true for n equals k plus 1 when true for n equals k, so it is also true for n or natural number when true for n equals 1. That would be it, just a pattern there. Now, and we have part C as well. Determine the value of n for which. Is that the same thing? It's just 8 multiply the left-hand side here, if I notice. Okay, so we're just going to use the formula. So that's 8, yeah, times, so instead of, this is going to be n multiply that. So this is just like this. You just plug in the formula there, right? Divide by 4. So that's the left-hand side of part C. And then we're going to put that equal to, what is that? Is that the, okay, it's the first part. All right. So it's exactly the same in it. So we're just going to do exactly the same there. What was it again? AN. Okay, where was part A? Part A is 4n, n plus 1. So it's 4n minus 1. 4n minus 1 in it. Okay. Yeah. All right. Everything is good. Yeah, I just check everything if I copied everything correctly. That cancel that, get 2. 2 cancel that, get 2. Okay. n plus 1 cancel, good. N cancel once, good. So what do we have? We have just n, 9n minus 7, because I wouldn't expand all that, right? And 2 times 4n minus 1 here. Wait, do we also have a 3? So I'm just going to do 3 here, because 3 can multiply on the left side. Just double checking the cancellation here. Yeah, that should all be good. Okay. So we have 27n squared here, and minus 21n equals 8n. Gotta be careful with how I write equal sign. Minus 2. Collecting terms, so 27n squared minus 29n plus 2 equals 0. We expect some positive integer, so I'm just going to guess 9n and 3n here. 2 and 2, does it work? Nope. Okay, it's going to be 27 and 2, I think now, because I see it's 29. Yeah. Okay, so it's 2 here and 1 here. Minus, minus. Yeah, that works, right? You add up to minus 29. So n is just 2 over 27 or 1. But n must be an integer, right? Because it's series here. It should be an integer. So n equals 1. That's weird. Okay, we work all the way so hard to just prove that n equals 1. Fine. Be like that. Number 9. Okay, so we get the parabola. Determine the exact length of QR. Okay, so directrix is just minus a away. Okay. The point P lies on these C at distance 5 units from the focus. Point P lies on C 5 units from the focus. All right. The point Q and R lie on directrix C. Q and R on directrix C, where PQ is equal to PR, okay, is equal to 10. Determine the exact length of QR. QR. All right. I'm thinking here. Okay. So let's assume that the equation is y squared equals 4ax first, where a is the distance from the focus to the origin and the origin to the directrix. Okay. And so the focus here, yeah, is going to be a from the origin. Yeah, we know that. And we know PQ, right? Okay, so this is point P. This is directrix. So this distance is the same as PF. PF and that distance is the same by definition of the parabola here, like this. Okay. Okay, so if this is x, then y must be 4ax, right? Square root. But PQ is 10. Okay, hang on. This is new. This distance here is 10. That distance also 10. P lies on C. Oh, 5 units away. Oh, we know this is 5. Oh, so this is 5 also. Okay, we got that triangle now. So that triangle here, you focus, yeah? This is 10, this is 5, because it's telling you that P to focus is 5, so this distance should be equal to that distance. That means the vertical distance here, yeah, we want to find QR. So it's just 2 times this distance, right? So QR is just 2 times square root of 10 squared minus 5 squared, basically. So that's 2 times square root of 75. Root 75 is just 3 root 5. No, 5 root 3. So that's 10 root 3. Yeah, exact distance. That's it. Okay, didn't take that long. And I'm done. Okay, so I think I'm okay with that, I think. So you need to know the definition of the parabola there. P 5 units from focus C. Okay, yeah, I think I'm happy with those. Yeah, okay. Just using the definition of parabola there. And I told you that I would go back and check question this one, right? This one looks the most like intriguing to me. So I'm just going to double check this one once. That's what I would exactly do though, because I'm not so sure about that, unlike other times. Okay, so we got that. Okay, you know what? I will try do on a separate page here. Yeah, reattempt. So I'm just gonna, so Z, because one root is that, right? I'm just gonna start from scratch maybe. So these are the two roots. So if we multiply that out, we get Z squared. And then the middle term would be, wait, hang on, yeah. Minus, yeah, this and this added together. So that would be 3 plus 5i plus 3 minus 5i. And that's what we got earlier, right? And this will be plus 3 squared plus 5 squared. Yeah. So that's one of the quadratic roots. So this is minus a 9z. And this is what? 9 plus 25 is 34 again. So that must be right. This one must be right. Yeah, this one must be right. This one is right, okay? And then I proceed to do this. Yeah? So let's check on this one, right? Wait, you know what? Let's do the long division. Yeah? Okay, we can do long division there. So let's do it. Wait, hang on. No, it's not going to work because we don't know what to divide there. Yeah, I think this is the only way to determine the value of P and Q. Yeah, you need to compare coefficient. Okay, let's double check the comparing work here with a weird coefficient set up here. So we did that. So the last term is 2. Yeah, of this one. Yeah, which I got here. And then what did I do? I checked the Z term, which is C times that, which is this guy. And this times this, right? Which is this guy. So that's minus 34b minus C is already 2, so minus 18 equals that. So I got 210 divided by minus 34, so that should be that. That's good, that's correct. And then what did I do next? I have a minus 36 here, which come from the cube term. Okay, so that's, what's that? Oh, okay, the cube is a times minus 9, so that's minus 9a, yeah. And then minus b times this, so that's minus b, and that's it. Those are just the two terms, right? And minus b, plug into that, I get a positive here, that's why this is a minus. Okay, and then over minus 9, I think plugging in the calculator, I should get that, yeah, I believe. Yeah, that should be right. And then I take that a, and then take everything here. Yeah, and then I multiply by 51, right? I get this. Yeah, this is fine. So P is going to be this, multiply that, so it's that. And Q is the second order, so it's that multiply, wait, that multiply that. Oh, hang on, that multiply that is this. And that multiply that is this. And 6 multiply, oh, 6 multiply, wait, no. 6 multiply this, sorry, is 6. Yeah, that should be fine. I mean, if I plug everything in correctly, that, yeah, I think I did. Yeah, you know what? I'm going to go with that. So I don't think, yeah, that's how I double checked and with under the time pressure. This one, did I say that I would go back and check? So I'm going to take out this page, if you don't mind. Wait, hang on. Yeah. Okay, so question 6, right? I think, should I double check that? Yeah, let's do it. 2 minutes. Okay. So, yeah, that would be minus 5 over 3. Yep, the first one is right. And then you would have minus k over 3. Yep, minus k over 3 equal to 9 times AB, alpha beta. Yeah. So that gives you 45. Yeah, k is right. 5 first expanding. Yeah, I believe that's right. Then part D. So part D, the sum of roots would be the sum of those two roots, which is this, and then that, and then the complete square, subtract away 2 alpha beta, because alpha plus beta is minus 4 if minus 15, so I got that. I'm just checking the method here. the calculator work, I won't check again. Maybe there's no time for that. And then C over A is just the product. I multiply that out. I get that. I simplify. Yeah, I think I'm going to go with these. And that's it, guys. So I'm going to mark the paper and we'll be in touch in a minute. Okay, guys. I have marked the paper. And I gotta say that I am not very proud of this one, honestly. But what's more important is your benefits. So I think I made sure that I annotated all the mistakes that I made along the walkthrough. And of course, all the 9 marks lost here were all from silliness again. So I'm just making a bad example here, right? You gotta be really careful, because some questions, when you lost 1 mark from silliness, it carries over. And that is bad. That is really bad, right? And it happened here for me, right? So I think I covered all the mistakes along the walkthrough. So I'm just gonna go. I'm just gonna do an overview, yeah, for all individual questions. So starting from number 1, this is typical. You make sure that you know how to find an inverse of a matrix. And you know how to play with the matrix equation like in part B. And how to find, the value of A. I mean, this is nothing too hard here. So I'm going to skip this one. Number 2 starts to be tricky, honestly, right? So again, the key thing here in number 2 is you know how to use the basis vectors like the I and the J vector to find the geometrical transformation matrix. So in this case, yeah, you can see that it asks for geometrical description for matrix P. Yeah, if you go back to the walkthrough in this question, I describe how we can use the IJ vectors to describe what happens if we use this as a transformation matrix, and you have to do that again in part B. So there's a lot of questions, I would say, relatively, that you need to know this technique, and where this technique is useful, actually, right? Yeah, I lost mark in part C, right? So part C should have been the other way around. So I mean, I did say that it's just a mirror image, but this one has got to go there. So this should be an I prime. It's like a swap, basically. And that wasn't so careful, right? That wasn't so careful. Yeah. I probably rushed a bit, yeah, on this one. Yeah, but so it should have been 0, -1, and -1, 0 instead. And this answer, follow through, wrong. This one is -1, this one -1, and this one, in effect, also -1. But I got some method there, right? So I kept losing marks there only because of that wrong transformation matrix. So you want to be really, really careful here, right? Yeah. So I made a bad example for you there. I hope you don't take that. So this one, yeah, this one is okay. I did okay on this one. Almost not made it, actually, because I kind of like blanked out on the bisection method, and that was right. So you just keep halving the interval and keep getting the interval where it gives you a change of sign. Yeah, so 0 to 1, and then you do 0.5, and choose between 0 to 0.5 or 0.5 to 1. And in this case, I chose 0 to 0.5 because it gives me the change of sign, and then you halve that to 0.25, and then you select the interval again because 0 and 0.25 gives us change of sign. So that would be the interval there. And then the linear interpolation method, yeah, this is fine, I believe. I double checked, yeah. And the, yeah, I mean, visually speaking, if you understand this in a similar triangles way, I think it's more intuitive. So you will not, I mean, it's more difficult you make a mistake because honestly, I don't have any formula here. I mean, I don't remember any formula. I just work by just interpreting the interpolation just like you find similar triangle. And they are the same thing. Yeah, it's just a manifestation of the same thing, but from different ways, right? So one manifests in graphical interpretation, the other one is in linear interpolation as in algebraic way, but this one is graphical, right? And that should be the right answer. So make sure you know how to do this, of course, and also the bisection method. Number 4 here, yeah, coordinate geometry. This one is typical, but part C might be a little tricky, I think. Yeah, because some people, I don't know, some people, it's probably obvious to those of you who already used to this kind of technique where you find the area of the triangle just using the base. Just pick the base where it's easy. And the base, when it's easy, is just the one that is already on an axis. In this case, the y-axis, because we already know the exact distance between these two. And yeah, I mean, most students I teach, right, would prefer looking at a triangle with the base and the height, like the height inside the triangle. But actually, what should have been taught for the whole time, yeah, the height is actually not like the internal height. It's just the altitude. So if you look at the triangle like this with your bare eyes, the altitude is just the distance from where you place it on. Let's say this is a table, and this is the height. So no matter how you look at it on the side like this, and let's say you look at it like that, this is the height. You have to be able to practice your mind to look at the triangle in this way, because when you find the area of it, sometimes it's not that easy to look at, because if you don't know that it's possible this way to look, then it's just hard. I mean, I'm saying this because I personally can look at it this way, of course, otherwise I wouldn't be speaking like this, but it's just that some students I teach, and most of them can't look at it this way, right? That's why I'm stressing this from real experience, right? So yeah, it's just that one trick you need to be aware of, because it usually comes up actually. They usually do it this way, yeah, when they ask area for a triangle. Now, number 5. Yeah, number 5 is fine. Everything is fine, right? Yeah. So this is playing with the complex numbers properties, and you need to know that when you have moduli of two complex numbers, when they multiply, you can put them inside together like this, or you can separate them. Same thing. That's how I got R there, and the rest is just fine. And you need to know that when you add two vectors, and it says that, yeah, it says that it's a real number, this implies that there's no complex part, there's no imaginary part, right? You need to know that that is critical to doing part B. And part C is just plotting them, right? So part B is the critical one here in this question, yeah. Okay. Yeah, this one took a while, and I made a silly mistake as well for number 6, right? We'll mention it when I go through them. Yeah, this one is fine, just roots of quadratic, so make sure you know how it works here, fundamentally. Part C starts to get a little trickier. First, well, luckily it asks you to, build some groundwork about using the alpha and the beta here from the simple quadratic to do something else on the other quadratics here. So that's the sum of cubes can be derived into this. You should know that, yeah. And then part D, yeah, this is also classic. It's just that the classic is that they, based on a previous set of roots from one quadratic, they ask you to build up another quadratic equation with complicated nested roots from the previous one. So in this case, they just, compound the alpha and beta in a particular way. I mean, it doesn't have to be like this. It can be a much more complicated one, like alpha squared, beta squared. Who knows, right? But if you go through a couple of, or a few papers, you see that they can do anything. As long as you can find there is a certain way that you can work from the alpha beta. And in this case, yes, you can work through that by just what I did here, right? So the technique here is to find b over a and c over a first and put it in an equation. And you know, the silly mistake here is I got the right value, but I put 9 here. How stupid that was, right? Yep, but the method here is all perfect, yeah, except that that is why the numbers, well, actually, if this was 3, which is the correct one, yeah, the number is still big, but yeah, although I had some second thoughts there, I came back to check, I didn't see that mistake. Yeah, I admit that it's hard to see, honestly, under the time condition there. Yeah, so this is carry over there. Yeah, because I got, oh, hang on. This one is a separate mistake. Sorry, this is number 7. So number 7, yeah, you add them and you should get 6, not 9. That is a very obvious mistake that I made. Okay? Probably not my day today, yeah. I guess you can forgive me on that. Yeah, again, I'm not very proud of this paper, honestly, very honestly here. You know, I almost didn't upload this video. I'm telling you that, because it was like, oh, this is like a BS work, like, but you know, for your benefits, not mine, because I mean, I can embarrass myself as long as it benefits you guys, right? And that's what I'm doing here. So yeah, if this was 6, everything else will be perfect, honestly. Everything else is just perfect. That's why I got so bad sense of P and Q here. Is very big. They're very big there. But you know, according to the AI generated mark scheme, one of the smartest AI model, says that, well, it's just the final mark here that I lost. So everything is fine. Everything is a follow through here. Yeah, you follow through from the previous part. You use that, I use this, and then I find everything until the last part I got wrong P and Q values. And D was fine, yeah. Fine as in the method is fine. I use quadratic formula there because without using a calculator. That is referring to the function, yeah. But of course, you can use a calculator to do the arithmetics, like the plus, minus, times, multiply, and divide, yeah. There's nothing wrong with that. Number 8, yeah, another stupid mistake. And I'll mention that later, but this part is okay. This part B is okay, proof by induction. So make sure you go through the proof by induction on series. So again, there are 3 types in proof by induction: series, matrices, and sequence relation. Yeah, so I would say matrices are the easiest one because they're not going to do too hard algebra on matrices. This one is the second easiest. I would say series sometimes can be confusing for people, even for me sometimes, honestly. So maybe you should also look at those if you haven't, yeah, before the exam, right? Make sure you do. But this one is fine. But yeah, it took a while because the algebra is a little intriguing here. But you just gotta get it, yeah? Yeah, I finally arrived at that and proved that it was like this, yeah? Because if you put k plus 1 into the ends, you're gonna get this form, yeah? So that was fine. And then I concluded, get the mark there. But this one, already started off stupidly here, forgot to put 15 on there. Yeah, everything else is fine except the 15. So I lost the method mark from the beginning because I put a wrong equation there. Just have to be harsh to myself. And yeah, so I think I got 1 method mark for solving quadratic along the way. And then I lost 1 method mark and 1 accuracy mark, right? So yeah, that's part of the stupidity there. Shouldn't have happened. A bit embarrassing, honestly, but I just have to upload this video. All right. So yeah, this one is just using the answers to part A and B, honestly, right? And put them into an equation, and the answer should be n equals 5 for this one, right? Okay. Yeah, this one really tests your understanding, right? Thank God I didn't make any silly mistake here. But the key thing here in this question is that you need to know the most fundamental characteristic of a parabola like this one is that the distance from the focus to a point on the curve is the same as the distance from that point perpendicular to the directrix. That is the single most important fundamental about parabola. I can't stress this more enough, right? That is very important, because if you didn't know that, or if I didn't know this, wouldn't have been able to do this one, right? Because I knew that one, so I knew that the perpendicular distance to the directrix was 5, and then I could be able to do a Pythagoras to find half the distance and then multiply that by 2 to get the answer. So a hard question sometimes can be easily cracked by just a very key fundamental, and this is one of them. Yeah. So that is the critical part you need to know for this one. I'm stressing it. And that's everything. That was it. So I hope, although I did so bad on this one, you guys still benefit from going through the walkthrough and seeing me make mistakes, you know. And do check other videos, because I hope they also useful. So there are up and downs about my marks along the way, you know, can never be perfect. And stay tuned, because they keep coming, not just the walkthroughs, but on the topics and tricks and techniques. Yeah. And I hope I see you in the next one. Bye.